Again, whenever you have something like this, you always go with your numbers first. 4 over 16 simplifies to 1/4. Now go variable by variable. What's x over x? 1. And now this y isn't happy in the numerator. Send it down below, and you wind up with y squared times y, which gives you 1/4, or 1 over 4y cubed, excuse me. You're right. Yeah, 3 and 4, on this case here, on 3 and 4 on that packet, it's written a little bit weird. When you have h of x is x squared plus 4x, and I didn't catch this after I printed this out.
Because I did h minus g and then I tried times it by negative 5.
Yeah, you can't do it that way. Yeah, no, what it means is this. It means write down what h minus g is. So it's x squared plus 4x minus x plus 5, because I have to subtract both of these terms. And then it means substitute in negative 5 for x. It's weirdly written, and I promise you tomorrow it won't look like that. It'll be f of g of 3.
Then I had negative 5x squared, and I was like, they got like 7.
Can we ask questions?
Yeah, I'm getting to that as well. When you do that, you wind up with negative, you get 25 minus 20 plus 5 plus 5. So what is that? 15? Okay. And this is really worded weirdly. I'll make sure that if you have function notation like that, it'll be function notation you see. I just didn't catch that. It was my fault for not explaining it. So don't worry about seeing it exactly like that. So it's going to be the same thing with number 4 on that sheet. Yeah, you know what? Let's talk about that. Let's talk about the quiz. There's a couple of problems with the quiz that I wanted to make sure I went over with you guys real quick. For example, number 19, the very last question. Here was a find the inverse problem. When you have a find the inverse problem, you have to, basically, you're flip-flopping your x's and y's. So it's y equals 3x to the 4th. Then it's telling you to flip-flop them. X equals 3y to the 4th. Now you have to resolve that for y. When you do that, divide by 3. And then you have to take the 4th root. Which means now you have a radical in your denominator. Which means you have to rationalize. You have to simplify that out. You cannot have 4th roots, you cannot have square roots or any radicals within your denominator. So what you do is you go through a quick little process here. Is 3 a prime number?
Yes.
Okay, bless you. 3 is the same thing as saying 3 to the 1st power. Do you agree? All right. If I want to turn that into a perfect 4th, how many more powers of 3 would I need? 3 of them. So what I'm doing here is I'm going to multiply the numerator and the denominator by the 4th root of 3 cubed. When I do that, I get the 4th root of 3 to the 4th, which allows me for that radical to simplify out. In the numerator, what's 3 cubed?
Oh, cube, sorry.
So your numerator becomes, so it's the 4th root of 27x over 3.
How many people got that right?
3, 4, maybe. There was 3 or 4 of them that had it set up that way, and of those, I think only 2 of them were correct, but there were a couple people that just forgot one part of that.
Well, then you just take
17.
I just took 1 point off. I was very lenient.
Yeah, I
Very, very good.
16 and 17.
16, you're going to kick yourself. What's the cube root of 8? Cube root of 8 is 2, so it's 18 times 2.
Yeah.
What's the cube root of 27? 3. What's 3 times 3?
I added up for some reason.
See what I'm saying? You're going to kick yourself? Yeah. And I'm not trying to belittle it. There's a lot of people that got that wrong. 17, yeah.
For number, I did one, square root of 1. Why don't you just do the square root of 1 times 1?
Yeah, the square root of 1, it just applies out to 1.
Yeah.
Because you're not supposed to have radicals in denominators.
This one I had absolutely
There's a radical there. You need to not have it there.
You're not having it in there.
Okay, if this isn't that the same thing? You're by your same argument.
No, because
It's okay, but that simplifies, doesn't it?
Yes, it simplifies too.
Okay. So what does this simplify to?
That simplifies.
Okay, then you have to write that. You have to write it down. Let's go through this one. Yeah, I got it.
What was the question that you proposed?
I'm sorry, what was that?
What was the number of the question that you
I think it was the last one on the quiz. This case here, you're basically taking the fourth root of each of those individual pieces underneath the radical. Is there a perfect fourth root that goes into 18? No. So that has to stay in there. Come on, guys. What? How many times does 4 go into 8?
Twice.
Any left over? So I can take out an x squared. How many times does 4 go into 9?
Twice.
How many are left over?
1.
So I can take out 2, leave 1 in. 4 goes into 3 how many times?
None.
So it all has to stay in. And you're done. There's no perfect root into 18.
Oh, okay.
It's not an exponent.
I was informed. Sorry.
That only works for the exponents. You got it.
Can you just do 11 really fast? I'm mad at myself.
Oh, yeah.
This breaks you out to be the cube root of 8 times the cube root of 5. So you have 2 cube root 5 times 4 cube root 5. A couple of ways of going about it. Now that I'm starting to think about this, I think this is kind of a garbage problem because I don't think we did a property like this. But here's the deal. If you write it out differently, it'd be, be 2, 5 to the 1/3 times 4, 5 to the 1/3. What do I do with those exponents then? Aren't I supposed to add them? Yeah, I should throw this one out. I'm going to change that one out on you guys.
So just +1 for everyone.
Yeah. I'm just gonna I'm probably just gonna kill that all out because that should be 5. That should be cube root of 25. Now I look at that, it should be cube root of 25. Yeah. I realized it was something I shouldn't. I didn't show you guys. And now that I go back and look at it, I missed it. What else?
12. Number 12.
What?
Don't say it. Have to have 5 in the inside.
Same base, different exponents, add. Same base. power to power, you multiply.
So if it's in like the 3 root.
Ladies and gentlemen, I cannot hear.
So if it's like 3 root of the cube root of a number, then it's just the number to the 1/3.
Yes.
And then I just go it out like that and then do it
Yeah,
instead of
if you want, yeah, that's fine.
And do that.
That's fine. Guys, I don't want to yell, but I can't, there's too much talking going on here. You have the test tomorrow, let me answer some questions, okay? Yes, sir.
12.
You have power to power to start with here. When you have power to power, distribute your exponent, which basically means you're multiplying everything across. So when you start to multiply your exponents in, you wind up with x 15 times -2/5 becomes, what is that, negative,
30 over 6.
yeah, so it becomes -6, and this becomes y to the 5th. No negative exponents. No negative exponents. What are you looking at?
Actually, there's one I forgot to mention. The square root of negative square root of
Square root of negative, what number is that? Not the b?
2. Yeah, I'm just simplify it. I have like no idea.
All right, you're gonna kick yourself here real quick.
For what number?
Don't kick me.
What's the perfect square that goes into 98? Better yet, what's 98 divided by 2?
Wait, what number is it?
This is number
Oh, it's not
8 on the B.
40.
So isn't it 10?
40.
You add them together and get a
See what I'm saying? A lot of times they're going to set you up when you have this adding or subtracting with one of the radicals will already be in a simplified form. So it's kind of like your hint to simplify the other one out. Does that make sense? You just missed it. What's that?
Adding it.
What's 7x plus x? 8x. I just can't add them together and eat the radical like that. That does not work. Okay, it won't work. What else we got? Jacob, which one? Which number 10? There's like 3 of them. On the quiz? These guys have same base, different exponents, but they are dividing. Same base, different exponents. When you're dividing, you have to look at who wins the battle of war. Who wins, 1/6 or 2/3? 2/3. 2/3. 2/3 is the same thing as saying 4/6. So that means it becomes 1 over 25 to the 3/6. 3/6 is the same thing as 1/2. What does the 1/2 power mean? There's your answer.
I feel ashamed.
Does this change when you do this? Do the x's just disappear? And you just have an exponent? No. It's the same rule. It's the exact same rule. It's the same rule when you have variables versus the same rule with the number. It does not change. It does not change, nor will it ever change. You treat it the same way. Is it the same base? Yes. It's the same base. Who wins in the battle of war? 9. What's 9 minus 7? 2. Answer, 1 over x squared. Same exact idea.
No, I know that, but no, I'm talking about like the 25 over 25.
That's the base.
Oh.
Because if you divide that out, you get a floating fractional exponent. Can't do it. Can't do it.
Floating fraction.
I just made that up. Pretty good, huh?
I guess.
You did that?
Can't do it. Yes, ma'am.
Picture.
10 and 14? Number 10 is telling you to write it out in exponential form, which means you have 1 over the square root of 6a. Now, what does the square root mean as far as an exponent? Do you remember? Half. So this is the same thing as saying 1 over parentheses 6a to the half. I would say stop there. I know the answer key had it written out like this. And I'd rather not deal with negative exponents. keep everything as a positive exponent, and that's fine. And I mean, it's basically then on number 11, remember your nth roots. Your nth root is the denominator, so it's 4x. Oh, I thought you said 10 and 11, sorry. Yeah, good.
Can you write that as 6 root of 6a over 6a?
That's not what it asks you to do. It asks you to write it in terms of exponents. What you did is rationalize. What you did is correct, but it asks you to write things in terms of the exponent. Do they have the same nth root?
Yeah.
What's $1.50 minus 50 cents? The answer is cube root of 10.
On the pancake, can you do 26?
I mark it right? You should have. It's cube root of 10. Plus minus. You don't have plus minus. That's why.
26 on the pancake.
I got this one.
In order to solve this problem, we have to get x by itself. We have to do a bunch of steps to get there. The first thing you're going to do is add 6. So in my calculator, I type in parentheses 191 over 32. I add 6 to it, and I get, oops, I didn't put negative there.
How weird did you guys get this out?
Yeah. And change it back to a fraction, you get 1 over 32 equals x minus 8 to the negative 5/6. Use your calculator, it doesn't lie. Now you got to get rid of that negative exponent. You got to turn that negative exponent to an exponent of 1, which means you have to multiply by its reciprocal. Or I don't want to say multiply by the reciprocal, you have to raise it to the power of its reciprocal. What's the reciprocal of negative 5/6? Negative 6/5. So you raise all of this to the negative 6/5. So I raise this to the negative 6/5. In my calculator, no matter which one I have, I use that little caret button, and I parentheses negative 6 divided by 5. Close my parentheses and hit enter, and I get 64. Add 8. Don't be alarmed by the weird looking fractions. Order of operations will set you free.
So if it was just regular 6 bits, I just times by 5.
Yeah.
It's-
Oh, not.
oh,
You
okay.
raise the exponent of
If
the.
it's just 5, 6, then I just swap it.
Right. So that's reciprocal. Yep.
I tried like 6 rooting it, the negative bit, and I was like,
Sad things, man. Sad things.
I got like 64 over 16 root something, and I was like, I got 7.
Yeah. You better not make a mistake. Smack you upside the head. What's next?
Yeah, it's like you think of like sometimes you download the games like they fucking 25 is so fun.
Yes, sir. What
What
else we got, guys? This is your time.
For this graph, write your speed graph y equals a root x, right?
Correct.
Would that be y equals a root 2x?
No, I've already talked about that. What has the exponent? So where does the 2 go?
Outside the x. Oh, 2 is the x.
Right.
Yeah, but you can only do like
What else, guys?
8 plays.
Yes, ma'am. Which one?
No, you get the unlock button.
Solve the equation, look for the extraneous solution. First thing I do is square both sides. I get -1 minus x is 9.
Plus 1 is
Add 1, we have negative x is 10, so I have x is -10. Now I have to check to see if that works. -1 minus -10 is 9, which is square root of 9 is 3. And it works. Oh, you're going the wrong way. Yeah. Remember, undo the square, or undo square root your square. Okay? Yes, sir.
Number 6 on the quiz.
Yeah, I got it.
Cube root of 24. Cube root of 24. What is the largest perfect cube that goes into 24? Well, that's cube root of 8. That's cube root of 3. What's the cube root of 8?
2.
So it's C.
it's minus
21 on the.
Wait, what?
plus 5 plus 5 plus
Square both sides to start with.
10. Negative x and negative 5 are the
Set one side equal to 0. Now from here I have to set it up, figure out my solutions. Well, that's going to be x minus, it's going to be x plus 1, x plus 1. So it's -1 is my solution. Can I take the square root and have it equal to a negative when I'm dealing with all real possibles? So that's a no solution. In this case, this is a no solution. In that case, it's no solution because when you substitute in, since we're dealing with all real values, that's what you get. 21. Yes, sir.
That would work. Because the -1 times the -2 makes +2. And 2 plus -1 has 1.
But does it? We're dealing with only real solutions, though. If I take the square, I'm not doing plus minuses here. All right. So I'm dealing. It's the square root of 1, -1. All right, and that's what it's. In this case, we're not looking at that. We're not flip-flopping signs here. It's just going to go straight for what the sign is. Okay. Yeah.
Can you just tell me what the domain and range is for 17 on chapter test B? See right there.
Let's see. Your domain would be. I'm guessing that this is going to be greater than or equal to 0. And your range is going to be y is less than or equal to 1. Or excuse me, greater than or equal to 1. Is that right?
And on the test of it, for domain and range, you want to say domain equals?
Yeah, or d, how I do it.
Just like x is greater than or
Yeah.
equal to 0.
Yep, that's all you gotta
I'm
do.
just so glad I don't have to even write domain and range.
No, just write d or r. We never really did that with those guys, so it's not that big of a deal. We're going to see that more in chapter 9. When you're looking at this one, the one that makes the best sense to show you domain would be number 12. If I say that I'm going to have x minus 1 over 2x, that's what that winds up being. Can't simplify anything and I'm done with it. What they're asking you here is to state the domain. If I look at this, what is the only value of x that I cannot have? basically it's what makes my denominator 0? 0. So my domain here would be all reals not 0. That's what my domain would be. In this chapter, I didn't really work a lot with domain arranged via this stuff, but we will see that again next chapter when we start talking about rational expressions. We're going to have x minus 2 over x squared minus 4. Stuff like that, we're going to be simplifying all that out. And we're going to say our domain arranged because you're going to have what are called asymptotes. That's what it looks like. Okay? Yes, sir?
Can you do 21 on the review packet?
I already did.
Oh. Alright.
Yes, sir?
Chapter test C, number 4.
It's not happy, is it?
Yeah.
So you have 1 over 216 to the negative 1/3. Two ways you can do this.
Can you go through the cube root way?
Yeah. In this case here, I can say it's 1 to the negative 1/3 over 216 to the negative 1/3. He's not happy. Now he's happy. Cube root of 1 is 1. He's not happy. Now he's happy. Oops. And the cube root of 216 is 6. All right.
Is there a non-carbon?
I haven't finished the test yet. I'm leaning towards yes.
No, so you just split
Wait,
the
what
part.
part would you
Probably graphic.
Oh, good, it's easy. So like, the cube would have made you work to this.
It's the.
Yeah, I see.
I'm on test B for 60, it says actually symbol 0, what is that?
Not equal to 0. It's saying that it's telling you that the inverse will exist. It's just review stuff that you guys really do.
It hasn't moved.
No. This is, I mean, the other stuff that I've told the other class is if you guys are back in your Chapter 7 stuff on the website, there are review problems at the end of the book. Go back over those. Test is very straightforward. There shouldn't be anything that's going to really freak you out on any of it. It's very, very, bless you. I think it's a very fair test. There's nothing. If you understand your exponent rules and how to set up and go through, you're going to be just fine. Okay? So.
I get it.
Okay.